Have you ever wondered what a flower is made of? Or the feathers on a bird? Or what makes up the clothes you're wearing? Have you ever thought about what water is made of? Or air? Or snow? All these things are made of matter. Matter has mass and takes up space. Or in other words, it has volume. But what is matter made up of? Matter is made up of tiny particles called atoms. What do these particles look like? What's inside them? And what makes them different from each other? During the next few minutes, we're going to explore these questions and others as we explore the fascinating features of atoms. This is a piece of copper flashing. Let's cut it in half, then cut it in half again, and then cut it in half again. If it were possible to continue to cut the copper in half, what's the smallest possible piece that we could make? The smallest possible piece is an atom. But exactly what are atoms? Let's take a closer look at this question. More than 2,000 years ago, the Greek philosopher Democritus stated that matter could not be divided into smaller and smaller pieces forever. Eventually, the smallest piece of matter could be obtained. This idea was largely forgotten until the early 1800s. That's when English chemist John Dalton began observing the activities of weather by studying gases. Through his experiments and observations, Dalton developed the basic ideas of the atomic theory. Dalton concluded that pure substances called elements are made of extremely small particles called atoms. He stated that atoms of the same element are exactly alike, and the atoms of different elements are different from one another. Dalton also stated that atoms could not be changed into different types of atoms by chemical reactions. He also theorized that compounds are formed by joining the atoms of two or more elements. These ideas served as the basis for what is known as the atomic theory. Late in the 19th century, in 1897, another scientist by the name of J.J. Thomson hypothesized that atoms are made up of even smaller particles. Thomson conducted experiments in which an electric current was passed through tubes pumped almost empty of air. You observe. What do you see when the electric current passes through the tube? You can see that light is given off. This light is created by rays traveling through the tube. Thomson observed that when a magnetic charge is introduced, the rays are deflected. Thomson reasoned that the rays were made up of negatively charged particles. Today, we call these negatively charged particles found in atoms electrons. Thomson also hypothesized that positively charged material existed in the atom. In his model of the atom, he proposed that an atom was made of a positively charged material in which negatively charged electrons were scattered. His model of the atom became known as the plum pudding model. He envisioned small electrons embedded in the atom, much like raisins embedded in a plum pudding. At about the same time, Henri Becquerel, Pierre Curie, and Marie Curie were learning fascinating things about the way certain elements emit energy in a process called radiation. In 1911, building upon the previous work of other scientists, Ernest Rutherford, a British scientist, developed a revised theory of the atom. In one famous experiment, he fired a stream of positively charged particles at a thin sheet of gold foil. He observed that most of the positively charged particles passed right through the gold foil. He concluded that the particles in the gold foil contained a great deal of empty space, contradicting Thomson's ideas of a solid atom. And while most of the positively charged particles passed through the foil, some bounced directly backward. Knowing that positive charges repel each other, Rutherford concluded that atoms were made up of a small, dense, positively charged center, which repelled positively charged particles fired at it. He named the center of the atom the nucleus. Rutherford hypothesized that the positively charged particles were concentrated in the nucleus of the atom, and negatively charged electrons were scattered around the space outside the nucleus. In 1913, a Danish scientist by the name of Niels Bohr improved upon Rutherford's model of the atom. While Rutherford proposed that negatively charged electrons were held in orbit by the positively charged nucleus, he did not describe the location of the electrons. Niels Bohr proposed that electrons move in orbits around the nucleus, and he proposed that these orbital paths, or energy levels, are located at various distances from the nucleus. Today, we refer to Bohr's theory as the Bohr model of the atom. Today, we know that all matter is made up of tiny particles called atoms. In fact, atoms are the building blocks of matter. As we discussed, many scientists over the centuries have contributed to our present-day understanding of the atom. We now know that atoms are made up of smaller particles called subatomic particles. The three main subatomic particles include protons, neutrons, and electrons. Protons are positively charged subatomic particles located in the nucleus of an atom. Neutrons are subatomic particles that have a neutral charge. They're also located in the nucleus. Electrons are tiny subatomic particles that whirl around the outside of the nucleus. Electrons carry a negative charge. As we already stated, the nucleus is the dense core of an atom. The nucleus contains over 99% of the mass of an atom. However, it occupies only about 1/100,000th of the space. If we let this marble represent the nucleus of an atom, it would occupy this much space in the football stadium, with the electrons orbiting at the far ends of the stadium. Within the nucleus are located protons and neutrons. Protons have a positive charge and also have mass. Scientists use a special unit of mass called an atomic mass unit, or AMU for short, to measure the mass of protons. One proton has a mass of 1 AMU. Neutrons have a neutral charge and a mass that is just slightly greater than that of a proton. However, the mass of a neutron is generally considered to be 1 atomic mass unit. You compare. What makes atoms different from each other? The answer lies in the number of protons. Different atoms have different numbers of protons. For example, a helium atom has 2 protons, and aluminum atoms have 13 protons. The number of protons in the nucleus is called the atomic number. Hydrogen, for example, has 1 proton and has an atomic number of 1, whereas oxygen has 8 protons and has an atomic number of 8. The atomic number of an element does not change, meaning the number of protons is constant. But the number of neutrons of an element can change. Believe it or not, atoms of the same element can have different numbers of neutrons. These are called isotopes. An isotope is an atom that has the same number of protons as another atom of the same element, but a different number of neutrons. The element carbon found in this pencil tip can be an isotope. For example, carbon may have 6 neutrons or 8 neutrons. The sum of the protons and neutrons of an atom is called the mass number. The element sulfur, found in this yellow stone, has 16 protons and 16 neutrons. You compute. What's the mass number of sulfur? The mass number of sulfur is achieved by adding 16 protons and 16 neutrons to get a mass number of 32. In nature, a sample of a given element contains a mixture of the isotopes of that element. For example, carbon can exist as carbon-12 and carbon-14. These isotopes are averaged together to get the atomic mass. Atomic mass is a weighted average of the isotopes of an element. Carbon has an atomic mass of 12.011, which represents the average mass of its existing isotopes. While neutrons and protons are small, electrons found swirling around the nucleus are even smaller. In fact, electrons are approximately 1/2000th the mass of a proton or neutron. While electrons are extremely small, they do have a charge, a negative charge. In atoms with an overall neutral charge, the number of electrons equals the number of protons. Electrons orbit the nucleus at extremely fast speeds. In fact, electrons may speed around the nucleus 1 billion times in 1 second. Scientists refer to the general space that electrons occupy as the electron cloud. The electron cloud can be thought of as similar to the space where bees are found swarming around a hive. Electrons are locked into certain areas within the electron cloud. These areas are called energy levels. Electrons with a relatively low amount of energy have their electrons located in energy levels close to the nucleus, whereas high-energy atoms possess electrons located farther from the nucleus. The arrangement of electrons in energy levels is very important in determining how an atom will interact with other atoms. During the past few minutes, we've explored some of the fascinating characteristics of atoms. We saw how our understanding of atoms has increased through the work of different scientists such as John Dalton, who stated that an element is made up of the same kinds of atoms, and that compounds are made up of 2 or more different kinds of atoms joined together. We saw how J.J. Thomson's experiments led him to believe that atoms are made up of smaller particles. Ernest Rutherford built on Thomson's ideas and stated that atoms possess a positively charged dense nucleus surrounded by negatively charged electrons. In 1913, Niels Bohr proposed that electrons move in definite orbits around the nucleus, which we now refer to as Bohr's model of the atom. Today, we know that both protons and neutrons make up the nucleus of an atom. While the nucleus occupies a small amount of an atom's space, it represents 99% of its mass. Finally, we discussed how swirling negatively charged electrons form an electron cloud around the nucleus. So the next time you look across a room or take a walk, think about the atoms found in matter. You just might think about your world a little differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1. Has mass and volume. Number 2. An is the smallest complete particle of matter. Number 3. The three main subatomic particles include protons and electrons. Number 4. Possess a positive charge. Number 5. Protons and neutrons make up the Number 6. A neutron has a mass of about Number 7. An atom with 6 protons and 6 neutrons has a mass number of Number 8. The atomic number of an atom is equal to the number of Number 9. Have a negative charge. And number 10. Electrons orbit in paths called levels.